Yes, in this video I will be telling about property of scalar product or dot product. Property of scalar product or dot product. Though definition itself is complete and tell everything about, but again we specify some properties of scalar product. Number one, scalar product. Scalar product is commutative. Commutative. That is, vector A dot B equal to vector D dot A. Because it is scalar, want to show the product, scalar product of two vectors is again commutative. Simply we have to run. Number two, scalar product is distributive over addition of vectors, that is vector A dot vector B plus vector C equal to vector A dot B plus vector A dot C. So this is these two properties. Now the vector product, scalar product is commutative, and number two, it is distributive over addition. Now number three, we come here. If vector A perpendicular to B, that is angle between the directions of two vectors is 90 degree. Then very simple, A dot B equal to modulus A modulus B cos 90, and everybody knows cos 90 is 0, so it is equal to 0. So here we can say that, and you have to remember this, it will be applied many times. So scalar product or dot product of two mutually perpendicular vectors is 0. The vectors which are perpendicular vectors are also called orthogonal. The vectors which are perpendicular to each other are also called as orthogonal vector. And therefore you can say, actually just you see x, y, z, these are three vectors along x, y, z, x unit vector, they are orthogonal. and hence we can say here क्या भाई here you know there are we use three axes x y z. I mean here component unit vector of this direction is I cap, here it is j cap, I mean, and it is k cap. So I dot j is equal to modulus I1 modulus A1 cos 90 0, and j cap dot k cap 0, k cap dot I cap 0. Now simply I dot j also 0, k cap dot j cap also 0, and so on. So you have to remember this property that the scalar product of two vectors which are perpendicular or which are orthogonal is 0. Many questions come on this topic. I will be discussing here. Now number 4. If vector A parallel to B, vector A parallel to B, that is angle between the directions of two vectors is 0 degree, then modulus A dot B is equal to modulus A modulus B cos 0 1. So it come out A dot A modulus B, or simply write AB, and that is why A dot A is modulus A square, modulus A into modulus A cos 0. Remember here, you can't write vector A and square, whole square, modulus, because we know only two products. We don't know how to square a vector. We can take dot product of two vectors, we can take scalar product, or we can take vector product. So this is this, and hence I cap dot I cap is equal to modulus I1 modulus I cap 1 cos 0 1. So it is 1. J cap dot j cap, it is also 1, and k cap dot k cap is also 1. These are some simple properties which are present in the definition itself. Vector A dot B is equal to modulus A modulus B and cos theta. All these definition properties are present in definition, but for sake of simplicity, we tell them separately. These are properties of scalar product. Now I give a simple question here regarding the dot product. A simple question here, please note it and try to understand basic things. Actually, learning of everything appears to be difficult, but when we get the thing done, it appears very simple. Okay, let vector A equal to 2I cap plus 3j cap plus 4k cap, and when arbitrarily I have taken vector A is this. Vector B, I say it is 3I cap minus 4j cap plus 5k cap. Simply I have taken. So कहता है क्वेश्चन है फाइंड find scalar product. Yeah, find A dot B. Find A dot B. Please make this dot very impressive. It should appear from first sight. The dot is there. So people ask you have told here A dot B is equal to modulus A modulus B cos theta. So there is no theta. How to find out theta? So this is not the problem. I have told you further properties I dot I1, I dot J0. So we have to use solution. Vector A dot B. We will write here like this. Equal to 2I cap plus 3J cap plus 4K cap dot. I mean 3I cap minus 4J cap. I mean or plus 5K cap. So 2I dot 3I. 2 3 are 6 I dot I1. So 2 3 are 6 I dot J0. I dot K0. J dot I0. J dot J1. So it is minus 12 here. Then J dot K0. K dot I0. K dot J0 and it is K dot K1 5 4 are 20. So it is 26 minus 12, that is 14. It may be any quantity that will be told later on, but simply here my aim was to tell you how to find out the scalar product of such things, such two vectors. So very simple. Actually this vector product, scalar product or vector chapter itself is here to understand physics. It is not just to tell you mathematics and physics. Actually these vectors are taught in class 12 in mathematics. I have told you earlier also that all mathematics in class 11, 12 and in higher classes is there to understand physics and some part of chemistry also. Because lot of calculations, lot of laws are there which are governed by mathematics rules. So we have to learn that mathematics. Differential integration, trigonometry, probability, these all are involved in physics. So whatever you taught in mathematics, please learn that carefully. Some more examples are there. We will take in next video because people feel bored when video is lengthy. Please be happy and learn happily. Don't take learning as a responsibility and enjoy it. I told you, if you are a fighter, you will be winner. If you will not fight, you will lose. Thank you.